Hello Math 2 students. This lesson's on similar polygons. You guys just got done with the lesson on ratios and proportions, and we'll use that idea to help define what similar polygons are, and then in addition use the ratios and proportions to find the length of missing sides. So what does similar mean? If two polygons are similar, they are basically polygons with the same size and shape. Okay, so when I look at it, if I just take like two triangles, right? If you look at these, they have the same shape, but they are different sizes. Okay, the symbol for similarity is just a tilde. Okay, now what defines if two polygons are similar? One, first off, what gives a polygon its shapes? And it's the angles. So two polygons are similar if their corresponding angles are congruent. So if I look, these corresponding angles would all be congruent, right? And then corresponding sides, they are not congruent, right? Corresponding sides are proportional. Okay, and that's the key. So when we take the ratio of the sides, right, they should all be equal. Now what is a similarity ratio? Anytime we talk about similarity ratio, all right, or another word is scale factor, right? Anytime we use these, what that means, it's basically the ratio of the corresponding sides. Okay? So, similarity statement. Anytime we have a similarity statement, we state two polygons are similar, right? So we would say polygon ABCD is similar to polygon EFGH. Okay, this is a similarity statement, and you have to remember, just like congruency, right, you must match up the corresponding vertices. Okay, it's very important to know and understand that. Okay, so what it says, determine whether triangles are similar. All right, if they are, write the similarity statement. So right now, the first thing we have to do is check the corresponding angles, right? And are they congruent? So when I look, angle A is congruent to angle F. Good. Then we know by the markings of the diagram, angle B is congruent to angle E. Then last, I know angle C is congruent to angle D. So right there, right, we know corresponding angles are congruent. So now we have to check for the corresponding sides. And we need to determine if the ratios of the corresponding sides are proportional. So what I do is I write the ratios of one triangle to the ratio of the other. So right away, if I look, AB, I'm going to write the ratio of AB to what corresponds with AB, ED. Or sorry, AB is not ED, it's EF, sorry. Then BC goes with ED. Then AC goes with DF. So right away when I look at this, the length of AB is 15, the length of EF is 20, equals the length of BC is 12, the length of ED is 16, then AC is 18 to 24. Now right now we cannot tell if these sides are proportional, but what we could do is reduce the fractions. I could divide 15 and 20 by 5. which reduces to 3/4. 12 over 16, 12 and 16 can be divided by 4, which gives me 3/4. 18 and 24 can be divided by 6, which would give me 3/4. Are the ratio of all the sides equal? Yes. That means the sides are proportional, and we can say triangle ABC is similar to triangle. What matches up with A? F. What matches up with B? E. What matches up with C? D. Okay? So, whenever you show two figures are similar, you have to show corresponding angles are congruent, sides are proportional. Now, what you notice here, right? Whenever you're given the similarity statement, right there, that similarity statement tells you everything you need to know without even having to look at the diagram. Many of us can look at the diagram and see angle E is congruent to or equal to how many degrees? Well, I know right away that these are supplementary. E and F are supplementary. So angle E is 180 minus 127, which is 53. So angle E is 53 degrees. But I also want you to notice A and E are in the same spot in the similarity statement. So right there, from that similarity statement, we know that these angles are congruent. And if you think about it, I could also state angle B is congruent to angle F. I know right away angle C is congruent to angle G, and angle D is congruent to angle H. And that's just by looking at the similarity statement. Okay, now, right away that tells me angle B then is going to be congruent to angle F, which is 127 degrees. Now the similarity statement also tells me the corresponding sides. AB goes with EF, then AD will go with EH. If I look, AD is down here, EH is down here. So right away, GH, right, the ratio of GH to CD is equal to FG, right, to BC. In these type of problems, I prefer to use a similarity statement versus the diagram. So here, are these diagrams, or these polygons going to be similar? So the first thing I always look at is angles right away, right? So when I look at this, what do all four angles in a quadrilateral have to add up to? 360. So if I do 360, they're telling you that these angles are 110 degrees, right? So if I do 360 minus 110, right, what is that going to give me? That's going to give me 140. So right away, I know B and D are congruent. So if I take that, divide it by 2, that's 70 degrees. That's 70 degrees. If I do the same thing over here, 360 minus 70, right, is going to give me 220. And when I divide that by 2, each of these angles is 110. So right away, I know angle B is congruent to angle E. I know A is congruent to, say, F. I know C is congruent to H. And then I could even say D is congruent to G. Corresponding angles are congruent. And then if I look, the ratio of all the sides would be 8 to 10, wouldn't it? So right away, right, I look at this, we're going to say A, B, C, D is similar to what matches up with A, F, G, H, E. And the similarity ratio here would be 8 to 10, or you could say 4 to 5. Okay? So what does this mean? Well, in this next problem, it says find the value of x. And they're telling you that right away, these two polygons are similar. So if I look at this, TS, right, goes with what side in the other one? In the similarity statement, it tells me it goes with NO. So I know I could say the ratio of 2 to X is equal to, if I look at the other sides I'm given, I know LM. What goes with LM? QR. Do I know the length of those sides? Yes. So I know the similarity ratio here. Because I know both of these sides, the similarity ratio here is going to be 5 to 6. Now notice here, I said ON to TS should equal LM to QR. Notice, I kept these sides are from the same polygon. These sides are from the same polygon. So when I write this, it has to be 5 to 6. Well, if I cross multiply to solve this, I get 5x equals 12. And if I do 12 divided by 5, I get 12 fifths, right? Or if I do reduce that, you get 2.4. So x is 2.4. Okay? So now here, I'm going to set up all the ratios. They tell you they're similar. So match it up by the sides. So I know z to 15 equals 5 to 10, which equals 10 to x, which equals y to 35. If I look, right, this side is 2 arcs and no arc there, which is 15. This side is no arcs. This side is 1 arc, no arc, 1 arc, no arc, and then 1 arc, 2 arcs, 1 arc, 2 arcs. So now what is the similarity ratio here? This here is your similarity ratio. So I'm going to take each of these ratios with a variable and set up a proportion. So me personally, I like to reduce 5 over 10 to 1/2. So I'm going to say z over 15 equals 1 over 2. Then I'm going to set 10 over x equals 1 over 2. Then finally, y over 35 equals 1 over 2. And when I cross multiply and solve, 2z equals 15. Z is equal to 7.5. Here, x is equal to 10 times 2 is 20. So x is equal to 20. And then here, 2y is equal to 35. When I divide by 2, y is equal to 17.5. And those are the lengths of those missing sides. So do me a favor, pause the video and go ahead and try this one. So if ABCD is parallel or similar to PQRST, what is the scale factor and the perimeter of each polygon? Well, first off, right, the similarity ratio here, or the scale factor, I'll put scale factor. If I look, it's AB goes with RQ. We don't have that. We have 6 to that, no, but we do have 4 to 3. So the scale factor is 4 to 3. So right now I know if that side's 8, this side is 8. If that side's 4, this side is 4. So we know the perimeter of this polygon is going to be 4 plus 8 plus 8 plus 4 plus 6. And when I add that up, 12, 24, 30. So the perimeter of this is 30. Now here, if the similarity ratio or scale factor is 4 to 3, I'm going to find QR by using the scale factor. So 4 over 3 is equal to 8 over RQ. And when I solve this, 4RQ is equal to 24. I cross multiplied this way. So RQ is equal to 6. So I know these are congruent to each other. If that's 3, this is 3. Now I have to find ST. So I know ED goes with ST. So I'm going to say 6 to ST equals 4 to 3. So I get 4 ST equals 18. So right away here, ST is equal to 18 divided by 4 is 4.5. So right away here, if I find the perimeter of this, 6 plus 6 plus 3 plus 3 plus 4.5 gives me, right, what would that be? 12, 18, 22.5. So the ratio of the perimeters is equal to 30 over 22.5. Now technically, right, the ratio of the perimeters is 30 to 22.5. I'm not going to go too in depth here, but if we did write this as a fraction, if you multiply numerator and denominator by 10 to make this 300 over 225, that would reduce to 4 over 3. Me personally, what I like to do is go ahead and take this and write the decimal. The decimal would be 1.33 repeating. What is 4 divided by 3 going to be? 1.33 repeating. So right away, you will notice that the ratio of the sides is the same as the ratio of the perimeters. Alright, so it says to find the value of the variable in each figure. Alright, so we have x and y. So right away, if I take the similarity statement and write the ratios of the corresponding sides, JL is equal to QS, LM goes with ST, then, you know, JM goes with QT, right? So now, once I know from the similarity statement what sides correspond, I'm just going to set these ratios up. JL is 3y minus 2 over QS is 5 equals LM is 6x minus 2. ST is 3, which equals JM 4, and QT is 2. So we know right away our similarity ratio is 4 over 2, or can we just say it's 2 over 1? So now I just pull this out, and I say 3y minus 2 over 5 should equal 2 over 1. When I cross multiply here, 3y minus 2 equals 10. Add the 2, 3y equals 12, y is equal to 4. Then I'm going to pull out the other ratio, 6x minus 3 over 3 equals 2 over 1. When I cross multiply, x minus 3 equals 6. So add the 3, 6x equals 9, x is equal to 9 over 6, which reduces to 3/2 or 1.5. So I know this is kind of rushed, but you can always pause it, attempt the problems, and go back to them. So go ahead and try the homework, and we'll see you on Wednesday.